Hello everybody, welcome to my channel. We will be continuing with our subject estimation and costing. So far we have discussed what is bar bending schedule and we have discussed two questions on how to prepare a BBS. Now today we are going to discuss previous year question 2022 winters. Now, prepare bar bending schedule for a simply supported doubly reinforced beam with following data. So doubly reinforced beam क्या होती है जिसमें कंप्रेशन जोन और टेंशन जोन दोनों में बार्स प्रोवाइड किए जाते हैं, तो उसे क्या कहते हैं? डबली reinforced beam. So size of beam is 300 mm into 600 mm. 300 mm is the width of the beam and 600 mm is the depth of the beam. Clear span of beam is 6 meter. Bearing on walls equals to 300 mm. Main reinforcement is 3 bars of 20 mm dia, out of which 1 bar is bent up. Shear reinforcement. Shear reinforcement means vertical stirrups. Vertical stirrups are used as shear reinforcement. They resist shearing. 8 mm dia, 2-legged at the rate at 200 mm center to center. Compression bars. Compression bars resist compression and these are provided in compression zone. These are 2 in number, 16 mm dia. End cover and clear cover to be provided is 20 mm. Now, clear cover to stirrups is 20 mm, end cover to bars is 20 mm. Stirrups are hooked around the main bars for a length of 8 phi plus 8 phi equals to 16 phi. We have already discussed this part in previous lectures. Clear span of beam is 6 meter, that is 6000 mm. Now the length of main straight bar will be clear span plus 2 into bearing minus 2 into end cover. Substituting the values, we get 6560 mm as the length of main straight bar. Length of compression bar will be same as that of length of straight bar. Now let's calculate the length of bent up bar. Length of bent up bar equals to length of straight bar plus 2 into 0.42 h, where h is the height of bend. H equals to d, depth of the beam, minus 2 into clear cover minus 2 into dia of stirrup bar minus dia of bent up bar. 600 minus 2 into 20 is the clear cover, 8 is the dia of stirrup bar and 20 is the 20 mm dia of bent up bar. So height of bend is 524 mm. Substituting the value of h in this equation, we get length of bent up bar. Now we have to calculate length of one stirrup. Length of one stirrup equals to 2 into x plus y plus 16 into dia of bar. 2 क्यों मल्टीप्लाई कर रहे हैं? क्योंकि एक इनर टू इनर डिस्टेंस यहाँ तक x ली है और इनर टू इनर डिस्टेंस यहाँ तक y ली है. 2 इसलिए इंटू कर रहे हैं, यहाँ पे 2x हो गए हमारे पास और 2y, इसलिए 2 मल्टीप्लाई करते हैं. नाउ x की वैल्यू कैसे कैलकुलेट कर सकते हैं? पूरे डेप्थ ऑफ द बीम में से क्लियर कवर डिडक्ट कर देंगे और डाया ऑफ स्टिरअप बार डिडक्ट कर देंगे, तो हमारा इनर टू इनर डिस्टेंस आ जाएगा x. सो x की वैल्यू हमने ऐसे कैलकुलेट कर ली है. y सिमिलरली पूरी बीम की विड्थ से हम क्लियर कवर डिडक्ट करेंगे और डाया ऑफ स्टिरअप डिडक्ट कर देंगे, तो हमें ये वाली इनर टू इनर डिस्टेंस मिल जाएगी. तो y इस तरह से हमने कैलकुलेट कर लिया. So substituting the value of x and y in this equation, we get length of one stirrup as 1704 mm. Now we have calculated length of main straight bar, length of compression bar, length of bent up bar, length of stirrup, one stirrup. Now we can arrange the data in the. Now last step is to calculate the number of stirrups required. Number of stirrups required will be effective span of beam upon spacing, center to center spacing between the stirrups plus 1. इफेक्टिव स्पान कैसे कैलकुलेट करते हैं? इफेक्टिव स्पान का क्या फॉर्मूला था? क्लियर स्पान प्लस विड्थ ऑफ वन बेयरिंग. Clear span is 6 meter, that is 6000 mm, and width of one bearing is given 300 mm. So 6000 plus 300 mm will be 6600 mm, that is effective span of beam. Spacing between the stirrups is 200 mm plus 1, that will be 33 number of stirrups required. Now we have calculated various lengths. Now we are going to arrange this in the table. Main bar, we have main bar, straight bar and bent up bar. Their dia are 20 mm, 20 mm. Shape is given here. स्ट्रेट बार हम स्ट्रेट शो करेंगे और बेंट अप बार कुछ इस तरह से शो करेंगे. स्ट्रेट बार हमारे पास 3 मेन बार थी, जिनमें से 2 स्ट्रेट थी और एक बेंट अप थी. लेंथ हमने कैलकुलेट करी स्ट्रेट बार की 6560 mm एंड बेंट अप बार की हमारी आई थी 7000.16. ओके, नाउ वी आर गोइंग टू मल्टीप्लाई द number of bars with the length and get the total length of that particular bar. 2 into 6560 mm will give 13.12 meter. Total length will be in meter. Now weight per meter. वेट पर मीटर हम कैसे कैलकुलेट करेंगे? डी स्क्वायर बाय 162 से. डी क्या हो गया? डाया ऑफ द बार. नाउ 20 स्क्वायर बाय 162 इक्वल्स टू 2.47. 20 square by 162, 2.47. Now total weight of that particular bar. Total weight equals to total length into weight per meter. Okay, now 13.12 into 2.47 equals to 32.40. This is the total weight required for straight bar. Similarly, we are going to calculate for bent up bar. Total length 7.00 meter into 2.47 equals to 17.29 kgs. Second is compression bar. Dia of compression bar is 16 mm. Shape is straight. Number of compression bars provided in the beam are 2. Length we have calculated. Length will be same as that of straight bar. Okay, now number into length equals to total length, and that is in meter. Weight per meter, d square by 162. D 16 square by 162 equals to 1.58. Now weight per meter into total length equals to total weight. Now last is stirrups. Dia of stirrups is 8 mm. Number of stirrups required is 33. Length is 1704 mm. Multiplying the number with the length gives the total length. Weight per meter, d square by 162. 8 square by 162 will be 0.39. Multiplying the total length with the weight per meter length gives the total weight of stirrups, that is 21.93 kg. So I hope this question was clear to you. Thank you for watching.